But Ben's got a fabulous topic on the slot antenna, and maybe he'll add in some of the other creations he's done. So, Ben, thank you so much. He's coming all the way from Canada, eh? So,
No doubt about it, eh?
and he's an hour ahead of us, so we really don't want to waste too much of his time. Take it away, Ben.
Hey, so everybody can hear me? Yeah, we're good. Okay, good. So yeah, let's see. My entry into ham was a couple of years ago, and it was one of those where I had some spare time. Excuse me. I had a little medical issue and I couldn't work for a bit. And then so I figured, okay, I'll just study up for my ham license. And so all things being told is I want everybody to understand that when I call myself the ham radio rookie, I'm 2 years young. Like I am about as rookie as they get. And I'm letting smoke out of machines and radios left, right, and center. So just bear with me, but it's the rookiness that kind of gets me along. And I figured well, here, I'm going to start a little slideshow. I'll probably jump back and forth here a little bit, but we will just share and then we'll do that and see if this works. Now, are you seeing that? Do we have the slot box antenna screen up there by chance?
Yes, we do.
Okay, cool. Sorry about that. I just want to, it's always good to double check. So, and I got a bit of a frog in my throat, so I do apologize. But we're going to talk about salt box antennas and why I ended up on them. But this is one of those situations where the antenna is not nearly as important as the materials that are used to build it. And this is where I think a lot of where I can sort of add into things. So basically, I want to have everybody embrace the rookie mindset. I want everybody to forget about all the things that they've been told about radio communications and what does or doesn't work. Now, yeah, there are some safety concerns and stuff that you do need to pay attention to, but like let the curiosity take you over. And above all else is embrace the scientific method. Question all assumptions. Any good scientific paper will be questions and or questioned, and people shouldn't, especially the writers, should embrace people questioning it. And I'm finding that for the most part, a vast majority of the hams are this way, but there's always that one or two hams that are like, that'll never work. And this is where I get to be able to use my rookiness to sort of play the game of, well, nobody told me and I'll just play dumb. And I'm going to tell you a story about the Faraday where I was on my HT in my backyard with one of the first models I ever made. And I was talking to somebody on the repeater and I was saying, hey, I'm going to make this really cool antenna. It's going to be made out of Faraday cloth and stuff like that. And the guy started laughing. He's like, it'll never work. And I'm like, okay. But like, copper transmits and this is a metallic fabric. And he laughed and he said, no, no, this will never work. And then I pointed out to him that I'm talking to him on it right now. And he was like, I don't believe you. And there's a coffee meetup with a ham group. And I got to go and meet up with the guy. And he still didn't believe me until we hooked it up to his HT and his jaw dropped. And this is one of those things where don't hold on to your thoughts so strongly that it ends up damaging where you can go or what you can learn. So I'm always using rookie as an excuse to make mistakes. I'm hoping that, like, maybe in my 70s, I'm no longer the rookie, but I'm hoping to keep the moniker because, well, it's just an easy excuse to keep going and doing silly things. So I'm going to lay some groundwork here is that before we jump into the box slot, I want everybody to understand that there's nothing new or great about the box slot antenna or the slot antenna. It's been done for many, many years. In fact, it was a big solution to how TV broadcast wouldn't interfere with radio broadcast, but still be able to keep a vertical tower. They wanted it to be horizontally polarized, but they didn't want to have the long elements out to either side to create this horizontal polarization instead of the vertical polarization that the radio stations had. Now, a box slot or a slot antenna, the feed point or the direction of the feed is the direction of the polarization. So the slot itself can be very tall, but it can be horizontally polarized if you feed it from the two sides. And the way I'm using it is just taking this TV radiator and turning it on its side, and then we're wrapping it up. And all of this is based off of John Portune's book, and we'll get into that here in a minute. But now, when you start getting into antennas, and this is where things I found kind of it was a struggle for me that I would look at HT antennas and getting feed line or ladder line and working with it. And it's cumbersome and it's a pain in the butt to work with and trying to unroll and trying to keep straight. And then once you have it straight, trying to roll it back up. Then you're looking at copper pipe, which is heavy and can be expensive, and then you need a whole bunch of tools to work with it. And I was thinking, like, there's got to be something better, right? And with the way things are now, there's a lot of materials that have made it so that you can build a lot of things now without having to go to these traditional materials. So before we get into the traditional materials, I jump around. I'm sorry, I'm ADHD. One thing I have noticed though is that it seems like the vast majority of hams are ADHD as well, so they seem to understand me. But so I want you to understand one thing is that again, I'm the rookie. Now my background's aeronautical engineering. I do know how to do calculus and I can work out some of the physics of some of this stuff, but I'm not the guy that normally goes into the bean counting or the numbers. I'm the rookie, and I'm not ever going to pretend that I know the physics or the how of how some of these things work. I've got some postulations, there's some hypothesis, and I might even write out some of this stuff, but there's a very good chance that I'm going to be either right or wrong. Now, let's just go back to the whole scientific method and being able to produce something and allow people to question you, right? So I'm going to allow anybody to tell me that, like, no, I don't think this is right, but that's great. You're going to have to prove me wrong. That is the one caveat that I have. So, but with that comes is that let's do some reading, right? And where I got the slot box antenna idea from is John Portune's book, The Slot Antennas for Ham Radio, The Forgotten Antenna by John Portune. Now you can get this on Amazon through Kindle, and I believe you can order hard copies as well. I'm not too sure. And there's another book that I recently stumbled on, and this is a beast of a book. Like it is a good 3 inches thick, and it's got pretty much every antenna, and it's a recent translation, English translation from a German book, but it's Roth Hamel's antenna book. Highly, highly recommend that you get it. It's expensive. It's worth every cent. So if you decide to go out and start reading about books, ARRL and all the other books, they're all great. They have great reading, but this has got sort of a different flavor. And it's got the one thing I like about the Germans are is that it's a no BS. This is the antenna. This is what they say it should do, and this is what we tested it. And there is no sort of everything's black and white with them for the most part, and or in the book, and it makes it easier to pick out designs that you want to play with. So where I shine and where things seem to be able to work with me and my sort of unique selling proposition or my superpower here is that I'm an aeronautical engineer and I've worked for 20 plus years freelance. And out of I would say the last 10 years, yeah, actually about 8 years, I ended up designing special effects and props for movies. And I started doing some very large robotic projects and stuff like that. I've done a lot of mechanical things, but with that, when you're working on props and special effects, is that you're always going to be exposed to new ideas, new amazing materials, things that should or shouldn't do things. Like you're always looking for that new sort of special sauce to make your life easier. And one of the things that I found is that I don't look at the world like most people do. Now, go into your hardware store and don't look at the pipe or plumbing as pipe or plumbing. Look at it as radiators, or go into the blind section and take a look at some of the rods and stuff that they have there. Is it metal? Is this something that you can turn into um, into an antenna or something of that nature. And look at the function of the item. Don't look at the form of it. Yeah, get rid of all the names for what things are. Plumbing pipe is no longer plumbing pipe. Plumbing pipe is now antennas. Turns out that I found out that tape can be antennas as well. So some of my initial discoveries is that kind of on a bet and a joke, I was talking about how I was building a whole bunch of antennas and I was just using plumbing parts and other stuff. And some guy goes, well, you know, is duct tape electrically conductive? And I'm like, no, I don't think it is. And yes, I'm going to go just jump ahead a bit. It is called duct tape, not duct tape. The history behind that is that it's made from duck cloth or duke, which is sailcloth, and then they put adhesive onto it. And then that was used to seal off ammo boxes, I believe, in World War II or World War One. I can't recall which. But if somebody wants to, I'm going to go down fighting saying it's duct tape, not not duct tape. But let's go back to doing an antenna. So I was looking at all these J poles that I was making using ladder line and copper pipe, and either they were heavy and cumbersome or they were awkward to use, or were simply a pain. And I recalled using some copper foil tape in some of my special effects. A lot of the things that I've moved or done mechatronics on, you'll end up having a wiring harness, and the wiring harness itself will probably go over something sharp, and eventually that wire will break. And one of my really quick fixes, and you have to be able to fix things super, super fast. Going in and trying to solder something or splice it is nearly impossible, and you can use heat shrink and special ties. But the one thing that I found that would work for like 30 seconds to get the shot and go in and just redo it is this copper foil tape with an electric background or electric adhesive on it. And that was great. So I made this duct tape antenna, and it ended up being like I put it on my YouTube channel. I'm fairly new to YouTube channel. I had a couple hundred followers. I didn't think much of it, and I thought, hey, this is fun, and I had a blast. The absurdity of talking to somebody on an antenna that's made of duct tape is hilarious. So put out that video and it kind of went a little viral. Actually, it went a lot viral, at least in ham radio terms, it went viral. And it's just made of copper foil and duct tape on the inside. I know you don't see it, but there's a J pole on the inside of this thing, right where the wires come in, and it works really well. And the reason why I have that second piece of tape on the outside is I thought, wouldn't it be great if this would last over and over again if it was in my pocket? So I spent the next month carrying it around in my pocket, seeing how long will this last before it fails? Is this something that could be viable? And you know, I had my wishes that this is something that's going to last a year, but it didn't. It failed within probably the first couple of weeks. The foil would work harden and break. Yes, you can always fix it, but that doesn't necessarily help things. Now, I'm just gonna see, I think I got my slides out of order. This here then ended up being me taking a look. Actually, you know what? I'm just gonna go to the next slide and carry on with this. So using the copper foil tape, I was looking at John Portune's book, which has this copper pipe version, which I'm capable of building, but like I haven't built one of these things, but I'm going to estimate that it's going to weigh probably 5 pounds, somewhere in that range. And you have to solder it all together. Once you've made some of the dimensional cuts, you can't back out from it. And that kind of stuff makes it very hard to experiment. This is the other thing I find about copper foil tape is that if you break the copper foil tape, you can literally just tape another piece of copper foil on top of it and it will effectively splice it. You can lengthen an element after you've cut it too short. So, you know, for those of us who cut immediately and then regret not measuring 15 times before they cut, this is like the magic tool of all things. In fact, I've used this to repair a few antennas by extending it out by just kind of folding it out. And you can use aluminum tape. When I say copper foil tape, it's my choice to use the copper foil tape. The reason I do use it is that the adhesive on the back of the copper foil tapes that you generally buy, don't buy it from the garden store, buy it from like Amazon, and it will say that it has conductive adhesive. is that, well, it has conductive adhesive. The other adhesives are not conductive, and when you lay one piece over top of the other, it will capacitively couple, and it probably will work for the most part, but it's not nearly as good as if you have that electrical contact. So the box slot antenna that I made there, that's made out of foam core bore about at the dollar store and some copper tape and a BNC fitting. I think all in it's maybe $10. Maybe. I bet you any money that it's probably closer to $5 to build one of these things. And this is where it's kind of, the tape has some really interesting properties that we're going to dive into here in a little bit. But it can handle a lot more power than people would expect, like a lot more power than people would expect. And that has a lot to do with the skin effect. So let's go back to materials. And I know that, again, hopefully some of you that came here to talk about slot box antennas is that, remember that the antenna design is a really good one and it's a very effective one, but it's just a design, and there's a million other designs out there. What makes the stuff that I build special is the materials. So I'm going to hop on that. So I know a few of you were like, for the love of, I came here for slot antenna. Follow along with me here. All right. So the materials in this antenna are what make it work so well. The shape is secondary. So when you look at all these foil tapes and everything like that, remember that you can attach these foil tapes to everything, including one thing that I've done that I've yet to do a video on is I've taped a J-pole antenna to the vinyl siding of my house, and it works like a hot darn. And it's just tape on the side of my house. No one would ever notice it if it weren't for a little wire that I have feeding into the back of it. So I ended up coming across Faraday tape a little later on after using copper foil tape, because I was looking at, could I make that duct tape antenna out of Faraday cloth? And I could find Faraday cloth. And while searching for Faraday cloth, I realized that there's Faraday tape, and my head exploded because trying to sew something down is a pain in the butt, but just taping something down is really easy. And I'm lazy. So it worked out to be the perfect solution. And there's a few properties that the Faraday tape has over top of the copper tape that you really want to be paying attention to. And one of it is that the surface area. Skin effect is a very real thing, right? Everybody knows that all the RF energy is generally on the outside of whatever wire that it's on. So the outside diameter of the wire, and this is why copper pipe J-poles work so well, is that they have a lot of outer surface area that can transmit, which then gives you a low Q antenna, but it still has a very good transmission because it's got a lot of surface area. Now, if you look at copper foil tape, it's effectively, if you look at the tape itself, whatever the width is, that would be the circumference of whatever wire that you normally would have used. And a very thin, flat piece of this tape can effectively be the same as a 1/4 inch diameter pipe, as long as it's, what, 3 times the size. So 3/4 inch wide copper tape is the same as a 1/4 inch pipe. And if you're looking at skin effect, let's double down on that and look, wait a minute, it's not just the top surface that's doing the skin effect, it's also the bottom surface that's getting the skin effect. So you're getting a lot of surface area out of this. Now let's roll this back into the Faraday fabric. Now the Faraday fabric is not fully copper and it's not fully titanium. It's a vapor deposition metal on top of all these fibers. But the thing is that at this point, you have very thin metal all over the place on a lot of fibers, and there's an insane amount of surface area on this fabric, more so than even the copper. I would even say, go as far as to say it's double the width of the copper. So if you're looking at a 1/4 inch of copper tape, or sorry, let me try that. 3/4 inch copper tape would be a 1/4 inch pipe. Well, a 3/4 inch piece of Faraday cloth, if you double that, then we're looking at 1.5 inches, and that works out to, 3/8 inch, I believe, 3/8, a larger pipe. How about that? And there's a few other things that happen within the tape, and I'm trying to work out the physics in this, and I'm trying to see. I'm almost at the point where I've made enough selling these antennas that I might be able to get a physicist to help me, because there's capacitive inductive coupling that's happening within all these fibers. On top of them, actually direct coupling because they're touching. But because of that, I'm finding things like I've got a 32-foot whip in my backyard that I call the random stick, that is nothing more than a carbon fiber pole. And I'm not going to go into using carbon fiber or glass, but just imagine that I have a piece of this Faraday tape, 32 feet tall in my backyard, and I don't have a tuner on it. Or sorry, I do have a tuner on it, but I don't have a balancer on it. And I think because of all this capacitive and inductive coupling, it's made this network where a lot of that backflow of energy just simply doesn't happen. And if it does, it doesn't get to my radio. So far, I haven't burned anything out, and it's been working really well for the last 8 months or so while I've been testing. So this is why Faraday tape, or the material, is like my magic sauce. And out of everything you can take from this is go onto Amazon and buy some 10 millimeter wide Faraday tape, 1 inch wide Faraday tape, whatever, and play with it. And it's so very easy that you can take something as simple as a dollar store box, tape some lines on it, and you will have a box slot antenna as long as you can work out a feed point, right? So that being said, this is also as literal as I can tape out an antenna on the side of my house. I don't have to build a superstructure out of metal. I don't have to cut wire. I just have to tape something down. And if I have the dimensions wrong, I shorten them. If I have them too short, I can lengthen them by overlapping them. So this is where the properties of the material is the key. So I want to show you a test that I did for slot antennas. Is that first thing I started realizing is that in that first picture that you saw for the slot box, you saw that the tape itself was vertically oriented as far as the flat side, but it's the edge that does the transmitting. So it doesn't have to be vertical, it can be horizontal as long as you have the outside edge of that slot box or that of the slot itself to transmit. And again, a lot of this you can get from John Portune's book as far as like the real science and everything behind it. Again, I'm the guy who builds things, and I just keep building until something works. But this antenna test was, I built 4 models, and I wanted to find out, how does the spacing between the top and the bottom plate affect the SWR and the readings that I have. So what we have here is a box that is about 8 inches tall, one that's 6, one that's 4, and one that's 2. So that gives me 4 different basic ideas of how this box slot can work. And you can work out the feed points and everything quite easily. I will show you as soon as I'm done this slide presentation how you can adjust this and tune this antenna for pretty much anything from, I would say, 2 meters on down to, I would say, 30 centimeters quite easily. But because of the way it's built, you can tune it. But for 4 built models for about $20, it took me less than 4 hours to cut out and get everything, right? I ended up finding this. Is if you start looking at the VNA results, is that the first one you can see had a very high Q, or a very low Q response rate. It's got a very large bandwidth, and this would be a good all-around antenna for something, say at your house or at your home, or maybe on your porch. And this is a 12-inch by 12-inch by 8-inch box, so it's something that could be hidden quite easily. But what happens when you start getting these 2 plates down closer together? And the reason I'm harping on this is that had I built that pipe version, I wouldn't have been able to adjust the feed points, and I wouldn't have been able to build this fast to find this stuff out. So as soon as you start you're squeezing this antenna down, you'll notice that you get a higher Q antenna. And then you look at so that would be the top 2 images there from left to right is the tallest to the mid-size. Then on the bottom row, you have the sort of the second mid-size, and then you have the 2-inch one. And you can see slowly but surely that the response, or the Q of the antenna, is suddenly improving. So this solved a problem of mine that I was trying to figure out is what makes the biggest variance in Q on these antennas? Is it the gap? Is it the material? Is it the orientation of the material? Prior to this, I figured out that I didn't have to have the material horizontal, I could have it vertical. So all of this testing can happen very quickly and be very empirical. And if you're somebody that's good with your hands, this is a lot easier than trying to deal with software trying to tell you what goes on. And as much as I love software and I work with computer aided design a lot, I've built some of the largest rotating structures for movies in movie history. And CAD doesn't solve everything. You have to build it to find some of those lessons. The empirical lessons that you get are the ones that really count. So I always find that building is basically where I really end up testing things. So with the fabric that, or with the Faraday tape, you can see the antenna that was mentioned at the intro is called the Faraday. And after my duct tape antenna video went out, and I then found out about the Faraday cloth and then the Faraday tape, I built one, and I put out a video saying, "Hey, this thing works really well. Would anybody buy it from me?" And I put out an email list, and I thought, "Hey, I'll get a couple of people. I might be able to get some coffee money." Um, the next day when I woke up, there was 500 people on my email list. A couple days later, there's 1,000. Now I have several thousand on an email list. I've sold, I'm coming in on 2,000 of these within 10 months. I had absolutely no idea how well received it would be, because when you take this rolls up into something that's about 3 ounces and will fit into your pocket, and you can deploy it pretty much anywhere. And I've got a 6 meter, and at the risk of um, advertising my company is VF Comms that I launched based off of this. And I sell these for 6 meters, 2 meters, GMRS, and 70 centimeters. And I also have been doing some specialty antennas for some government organizations for different frequencies. But let's get away from the tape and the go back into the slot antenna. Now, I made one video and I absolutely adore this because a can of ham, the triangular cans of ham that you have out there, um, they turn out to be almost perfectly resonant at 70 centimeters. It took me so little time. Now you have to get the cans where you peel out the side, or you have to cut the two halves apart, and then you space it out with some plastic, and you throw a jumper onto it, and you throw a feed point onto this. There's a video on my channel. This makes for an incredibly good 70 centimeter antenna. So I have the ham antenna, which I'm super proud of because it is so crazy, and the fact that it works so good is nuts. So, but the point of this one is that look outside of tapes, and look outside of the Faraday fabrics, and look outside of, find things that resonate, hook up to it, and see if you can make an antenna out of it. And you're gonna find that you're gonna surprise yourself at what will actually work. One of these days, I'm pretty sure I'm gonna make a salty wet noodle transmit. And I know a lot of people say that. I'm sure somebody has done it, but I'm gonna at least film it because I know it can be done. Um, so let's take all of this, and we're looking at everything I've talked about so far has been VHF and UHF. But what about HF? So when you look at squid poles, and I mentioned this before, is I have an antenna out in my backyard that's a 32-foot squid pole. It's carbon fiber. Now you could use glass fiber. It matters not in the way that you think, is that the carbon is not negatively affecting the antenna, or if it is negatively affecting the antenna, you standing close to the antenna is going to cause more issues than the carbon fiber will. So all I've done is run a piece of tape along the outside of this whip. And so far, my best single sideband contacts have been 13,000 kilometers to England. And I've gotten, or not to England, sorry, I've gotten down to Brazil. And then 14, I think it's 14,500 kilometers to the Antarctic on FT8. And I was getting some pretty decent reception. So anybody that tells me that the carbon fiber and the glass fiber doesn't work, well, those numbers, they kind of just fly in the face of it. It's one of those where I'm working out a way to explain this to people why it works or how it works, but all I do know is that it does work because I'm willing to try. So where you can find me is at YouTube. You're going to find me. I know it's a long name there at V6SFX, which is my call sign underscore Ham Radio Rookie. Ham Radio Rookie was already taken by somebody in Park, but that's where you're going to find a lot of the videos that I make. And I just go around and I don't take it too seriously, and I have some fun and I build things. And then VF Comms is something that got launched because of Ham Radio Rookie, and I went from doing movie and special effects and stuff to, and I love doing movie special effects, but I work less and make more doing these antennas than I do in special effects. So there's just gonna have to be some pretty special movies and stuff for me to do. So that'll be the end of my sort of slide presentation. Now let's see if I can figure out how to get out of this part here. Do to do. This is the one thing I didn't actually look at is how to get out of the Zoom thing here. Oh, or screen sharing. I got it. I got it. I think I got it. Do. So
You got it.
did I? Okay, so you got my face now?
Yep.
Okay, cool. So I'm gonna, am I doing okay for time? Because I just got a couple
Yes.
things I want to show.
Oh, yeah. Go right ahead.
Okay, so I've got a pile of antennas behind me I brought because I got so excited. So the slot antennas that you can get, I started looking at some new materials, and you're the first to see this, but this here is one of those box slot antennas. It's a full metal piece here, but this metal here is some material called die bond. Die bond is an aluminum sheet on a plastic substrate and then another aluminum sheet. So a couple of things I found is that I can get almost a notch filter antenna for a certain frequency by just using this alone. It's actually it's quite interesting, and I'm trying to see if maybe I could use this for a repeater without having to get the big can filters. But when you get two of these pieces and some 3D prints, you can put it together and get something that looks like this. So we've got a 2-meter antenna that will fit into a 12-inch mailer and be able to be sent out to some people. And it's a little more industrial than the card ones that I've had. And when you look at slot antennas, everything you've seen is this box slot, but all it really is a really long slot. And this is a slot antenna that can be wrapped up into or over top of a frame to be a box slot. But you can also just hang this in a window and use it as a vertical 2-meter antenna. And it's got all the gain that a standard dipole does. So when you put that into a frame, you end up having a box that's something like this. And this is something that you can throw into a backpack and hang from a tree or put on top of a trailer. And that's one of the things I've been doing. And let's see, you've got the extended or the random stick antennas, another video of mine that I'm pretty sure a lot of you find fascinating, but I've made a Moxon antenna, and this has a lot to do with the state parks and the military contacts. Is I'm making some antennas that are Moxon antennas. So you've got the radiating element is the front part here with, it's basically a folded dipole, and then you have a reflector on the back. This weighs 6 ounces. It will fit into your backpack, and you've got a directional antenna, and the gain on this so far on 5 watts, I've done a 300-kilometer contact. So that is, good grief. I'm trying to think in miles. It's about 170 miles out of this and 5 watts. So when you start looking at using some of these materials, it's a lot of fun. And I just want everybody to go out and play and make stuff with this stuff. It's amazing. So I guess that would be pretty much all I've got. I'm definitely open to any questions that you have, and hopefully, um, yeah, hopefully you've gotten something from this. If you haven't, please let me know that you haven't gotten anything from it and you think I'm a clown, because I
No,
can't get any better unless you do.
then it's actually quite fascinating. I know I already have some hands in the room, and then we'll grab questions from Zoom. In fact, all our Zoomites, if you could actually put your questions in chat, that way we don't have a pile up, that would be good. Um, But first off, once again, the slot box, you're designing it to actually be, take it as a kit. Like once you use it, you would take it apart, pack it up, and then,
Yeah.
so it makes it extremely portable.
Yeah, and there's one thing I said I was going to talk about and didn't, and this is another thing, is that with the slot box you have a feed point, but then the feed point to the matching area or the matching piece is where you get your 50 ohm sort of well, that's where you get your 50 ohms from. And then this here is how you get your tuning in. But what's really interesting here is that I've made these little just jumpers, so you can put this in here and you can tune it by just sliding the piece back and forth. So you tune in and you find your 50 ohm point, and this varies a little bit as you move this. But what I ended up finding out is with this antenna is that this is 2 meters, but this is, if you want, and yes, you can dual band it, but every antenna would be a compromise if you're doing dual banding. And yes, there are harmonics, but you generally want an antenna to be harmonic. So what I'm getting at is about there is 70 centimeters. And that was just all I had to do was move the jumper over here. Now, granted, this is no longer an omnidirectional antenna. It's definitely going to radiate a certain direction, but you've got something that you can tune, or you want something in the 30 centimeter band. Again, you just move it to there. So the slot antennas turn out to be really interesting if you can build it out of materials that can be very flexible. Okay,
Okay, great.
that
And,
spiel's done.
and just so you know, at some point here, people are going to start wanting to put an order in, so be prepared to answer that question. Let's get some people in the room. Well, how about we start from front to back? Then I don't have to go back and forth. Connie.
Hi, yes, I'm Connie, W6EFI.
Hey, Connie.
This is fantastic.
Thank
This is
you.
so clever, and I love your approach of being the rookie, just saying, well, I'm just going to try it, and I'll just be, I'll just
Yeah.
pretend I don't know anything, and, that's my excuse for trying it. And oh, by the way, it works. I love it. So,
Yeah.
yeah,
Yeah,
I'll be
exactly.
one of those people looking for ordering information. But my question, so something a little thought uh, came to me when you were sort of towards the end, showing the box that you've got the screen wrapped around with the
Mhm.
that looks an awful lot like some of the kites that I flew as a
Yes.
kid.
Oh, I'm
So
a
tell me
huge
all about your
fun kite person.
plans for using this cloth on a box kite.
Yeah.
That's my question. Thank you.
Yes. Okay. So, using it on a box kite, I agree with you, and I think that'd be really wise, especially if you're looking at, say, some of the 2 meter, some even a Baofeng or something like that, where you can do a crossband repeat. You talk to the kite via 70 centimeters, and the kite can go out on 2 meters, which then can get you a little more range. The box kite, I want to try for sure. It looks exactly like a box kite. In fact, it's about the same size as one of the box kites I have. You can see that, like aeronautical engineering, I've got anything that flies I'm interested in. So, but there's something I want you to take a look at, and there's a kite out there called the NASA Parawing. And it's literally a sheet that's tied together into this really weird sort of pillowy wing, but it's directional and steerable. So you have 4 lines going to it, and you're able to bring it not only up into the air, but you can orient it. Now, imagine that you take the Faraday fabric and you just put it over top, either in a J-pole or a dipole or whatever configuration that you want with your HT. And these will have more than enough power to lift that HT into the air. In fact, I've got kites that lift me off the ground. So if we're looking at taking an HF radio and putting it up there, it wouldn't be a problem. And if you use something like that, the reason why I'm saying that you want something that's steerable is that the box kite, once it's up and once it's got that orientation, you're kind of stuck there. And as we all know, sometimes just even being able to change the polarization, maybe have a horizontal polarization versus a vertical. If you had the NASA Parawing a kite, you'd be able to change that orientation and be able to park it in that orientation or park it in this orientation and be able to probably get better contacts that way. So hopefully that answers your question and lights up a few other fires in your head.
Very good. My name is Keith, K1OKS. I've played around with some slot design and such, and I had a kind of a somewhat related question and concept. You showed already that if you were to shorten down your box, as an example, you're simply raising your Q, and eventually it gets almost razor sharp on a
Yeah.
specific frequency. That's probably what I'm facing at this moment, but what my thought was to actually build a slot antenna using a PVC pipe. And what I've done is I basically curled copper tape, and I've also used Faraday tape as well, around the pipe, leaving a slot open and then crossing over at the top and the bottom, leaving a slot on one side.
Mm-hmm.
So as you can imagine, it looks like a copper pipe with a slot cut out of it,
Yep.
about ½ inch wide. And of course, that would be a very high Q. And trying to get a 50 ohm match on that, it's kind of challenging to get it tuned at the right frequency. But the idea was FT8 is available on 2 meters, and
Oh,
and
yes.
think about it. And so you're thinking you really want a horizontal polarization,
Yep.
and you also have a neighbor and perhaps an XYL who's not so interested in putting yet another antenna up in the backyard. But what if you used bowstring, which I'm doing, and that's what I'm designing, put bowstring through a PVC pipe, wrap the tape around the pipe itself, and then get some of that heat shrink tubing made for lithium batteries, which
Right.
happens to be a nice medium gray color and is also UV resistant. Now, find your sweet spot, tune it in, put the bowstring at the top of the thing, and tie down below with your coax going down using gray coax. Put the heat shrink tubing on there and shrink it on, and it matches the color of the tree trunk.
Oh, I love
It's
it.
up and down for orientation, but you're rotated 90 degrees off for your polarization.
Yeah.
You now have a horizontally polarized as needed for upper sideband, which is used for FT8 on 2 meters. And you could hang it right up at the top branches of the tree with a gray coax coming down the tree trunk.
Right. Yeah, well, wow, that's impressive. I love that idea. And the fact that you can get it like so high Q right within that frequency
Yep.
that you're probably not going to need very much power to get out.
Your inspiration is helpful. Thank you very, very much for telling me about, of course, the Q changes for the
Yeah.
slot width.
There's one thing I'd recommend is on my channel, I can't remember which video it is. I believe it's a video on its own, but I show how to make magnetic feed points. So I take a BNC connector and I attach 2 wires to it and then 2 neodymium magnets to just some circle crimps. Then you put magnets on the backside of whatever material you have. So if you're doing that and you're trying to find your feed point instead of taping and untaping, is if you use the feed points with these magnets, is you can slide them along and find it really close, or at least get you in the right range, then mark that with a Sharpie. Then you can start committing to like a permanent solution. But I find that like make sure that everything that you do can either be undone or fixed. And that's why I love the tape, because like you break the tape, you tape over the gap. But hopefully, yeah, I love the idea and I can't wait to hopefully you do a video or something of that. I'd just love to see it.
Thank you for the insight as far as the gap going so narrow, making it much more high on the queue. I didn't realize, and that's very, very helpful information. It will help me in the tuning process quite a
Yeah.
bit. Thank you so much. Pass on the next.
Yeah, and while you're passing it on, another thing that I'm doing you'll notice that I had 2 of those antennas is that of the box slots is that you can phase array them very easily. And as soon as you do that, you get a 6 dB gain. So maybe take a look at your slots and make like a small ladder. They don't have to be very far apart, a meter and a bit. And you've got a phased array slot with an exceptionally high Q. It should be pretty interesting. Yeah.
Oh, Andy, KR6DD. Hey, I got a big kick watching your video online where you're hanging this long duct tape strip or 2 strips with a a quarter inch
Yeah.
between. And then you got on a repeater in Alberta, and the guy responded to you, and you were bragging how great this thing works. It occurred to me, hey, the way you got those contacts on there is the way Keith has his, and it's for horizontal polarization. How come you got into the repeater so well?
Well, the repeaters here, actually, everybody around here, all our repeaters are horizontal, or sorry, vertically polarized. So that's one of the big things that we have going on. Maybe it's different in the US. I don't know.
Someone's saying the tape is up and down on yours, so
Oh, so the tape is up and down. Are we talking about the J-pole antenna, or are we talking about the slot antenna?
That might be the confusion point. Andy's actually asking, he was thinking that your duct tape antenna was an actual slot. Instead, I think it was probably your J-pole.
No, it was yeah, that antenna itself is a J-pole. And
That
you
makes
know,
sense.
suddenly this explains 2 or 3 questions where I hate saying it, but I argued with people going, no, this is exactly the way it should be. Not realizing that they didn't have the viewpoint I did. They're looking through my camera lens and whatever pictures I took. So I might have to eat some crow and apologize to some people. So thank you for that.
you know, another idea I thought, just radical, since we're talking about radical things, is the box slot looks like a bird cage or a bird's nest. That would go well in an HA, wouldn't it?
It would. I don't think the birds would like that exposure. You might have some three-eyed
With
bird
birds.
that's
Any more
coming in
questions?
spring.
Any more questions in the room here? Okay, we'll go over to Zoom. Let me pass it over to Ben. Ben, did you have anything?
There were 3 on Zoom, or 2 on Zoom.
Okay.
You
want mine?
Yeah. One from Zoom is K6SW asks, any HF antennas?
Yes. One of my last videos you look up is called the random stick, and that is an HF antenna. It's using like a carbon fiber pole, squid pole you can buy. The one I have it was like $30 US, landed to me. Actually with tariffs and everything now, I'm not sure exactly what that will be, but and I've just got Faraday tape on the outside. And what's really interesting about this is I'm gonna deviate a little bit and maybe add too much to this story is that a lot of people want to be able to collapse and collapse the pole and bring it back out. And if you have a long piece of tape, obviously you can't do that without cutting it. So what I did is that I put the tape in on each individual section and then reassembled the pole. And you can extend it out, but what ends up happening is that the tape itself you overlay it, and it capacitively couples through the carbon, and that ends up creating a bunch of like capacitors along the way that allow you to tune it. And not only that is that each section, and this is stuff that's slowly coming out. My videos are generally about 6 to 8 months behind what I've actually done. So if you take the 2 pieces of copper tape, if they're lined up like this on the squid pole that you've just extended, is you can rotate them. So you do this and you change the capacitance. And so you can start playing by tuning in specific bands along the route without having to collapse the entire rod. Anyways, yeah.
Question, quick, sorry.
Yeah.
Are you actually taping that on the inside or the outside of the squid pole? I know that would be difficult on the thinnest of sections.
It's all on the outside, and it's
But
a great question. I'd like to do it to the inside.
Roll
So
it. Roll it into a straw shape, and then just insert it into the part. You'd be limited as to how thin you could go, but then you wouldn't have any exposed tape. There would be no rubbing on the tape, and then the squid pole would behave as it was designed.
yeah,
Slide in and
but
out.
the tape is a lot more durable than you think. It's a very robust material. It's a polyester, and I've been beating the ever living bejesus out of one of my J poles. Has been through the washing machine. I think it's 15 times now because I'm just dumb and I leave it in my pocket, which is also great for testing, but it still works. And like scraped across trees. In fact, one thing I like about the Faraday fabric is that it also has a soft failure rate. Now, how this affects the transmission, I'm not exactly sure, but I've seen one of my antennas has had one of the main elements where it was cut 3/4 of the way through. It still works with a big gap in it. So there's not a whole lot of antennas where you can create a fracture like that and have them still work. But Anyways, next question.
Yep, and on the topic of the carbon fiber pole, I believe you had on your video indicated that for the tape, you were gonna maybe put a channel and then epoxy, so it would go in and out,
Yep.
and the poles wouldn't even know the tape is there?
Yes, I'm looking at doing that from a manufacturing point of view. It's difficult though. What I've landed on recently, and um, I'm just trying to think of what I can and can't share because I am working with, again, some private individuals. You know what? I don't see this being anything that would be outside of the ordinary. Is that you look at vapor metal deposition. You can start putting chrome or something down on top of carbon fiber or glass fiber, but you can also mask it out and create an antenna element based off of that. So what we're taking a look at is doing vapor metal deposition on the outside, possibly the inside, and then just doing a quick coat on the outside. I know that sounds very difficult to do, but oddly enough, it is less labor intensive than trying to tape stuff out and then epoxy coat over top. So it all depends on what I can actually bring to market and the way some of these things are being tested out. So yeah.
Cool, thank you. I think the concept of the coupling effect just solves so many problems. Okay, we're gonna go back over to Zoom questions. Hang on a second.
Yeah, so the first one is about the kite idea again, and I think related to talking about lifting a radio up with a kite. The question
Yep.
is, could you build the kite string out of a Faraday cloth so that you just use a, feed the feed from the ground?
You know, that's very interesting. Yeah, I've thought about that, and I can't see any reason why not. The polyester is fairly strong. The problem that I see is that a lot of these, it depends a lot on the kite and how much pull you have. Some of these parafoil kites and stuff, like I do some stuff called kite surfing or kite skiing, and they're enough to lift me off the ground to 50 or 60 feet off the ground, and I'll go flying for 200 or 300 feet, and then I'll land. So like this is the power of the kite. You got to have a string that can hold a 250-pound man dangling from it. Um, to get to that point with this material would require getting a hold of the manufacturer and have them weave it up. Now, so what I'm saying is that I don't believe it exists yet. It wouldn't surprise me if it does, but I haven't been able to find it. And I'm really good at finding all that really weird stuff. So I don't think it exists yet. Could it be made? Absolutely. So it's a great idea, especially if you're running, like if you had a 2-line stunt kite, you could run effectively a 450 ohm line, a dual feed line up to it, low loss, but you're also looking at running electricity along things that you're physically touching. And I don't necessarily see that as a good thing. And I also don't like the idea of maybe adding additional weight to the kite string itself. If you can just lift the radio up and talk to the radio as a repeater, then that's my belief is a better system. But again, go back to what I said before is like prove me wrong. I'd love to see what people would do, but that's not a route that I don't think I'll take.
Or you could run a second string, one string for
Yeah.
weight and control, and the other one just as of the Faraday cloth. Okay,
That's a very good point. Yeah.
Next question, I think the final question is, what have you found the power capacity for Faraday cloth? I imagine the surface area and any solid surface you tape it to may help with cooling quite a bit. Have you melted one for science?
I haven't been able to melt one for science. This is where I'm completely blown away. I need to, so my heritage is Scottish and I'm cheap as all hell. So I haven't bought a big amp. I'm part of a good club though, and we do have some pretty powerful amps that maybe I should try. But what I've done with my 6-meter J pole, which is the same as my 2-meter and everything, at least as far as material goes, obviously it's longer. I've jammed 70 watts through it, and I've put a FLIR camera on it, and the only thing that got hot was the feed point. Because all like you touched on a few things that were right, is that you've got a lot of surface area, but not only that is that you got a lot of surface area and it's a woven cloth, and even though it's a tight weave is that you got holes, so the air passage and everything, it just self cools. I've yet to have anybody melt one. You know what, I lie, I did melt one while I was doing wet weather testing, and I shorted it out between the feed points, and the feed points got hot and they melted through the cloth. But that was the only reason why. And this is, I absolutely love this, is I actually have SWR spray for my antennas, because with the fabric is that if you get a spray on waterproofing spray or a wax, it effectively waterproofs it, and it will make sure that when these antennas get wet, the SWR obviously goes up a little bit. It shorts it out. It still works, but you know, it doesn't work as good. So you can use my SWR spray and fix your antenna by just making it waterproof, which I just love the tongue-in-cheek cheekiness of this, is that, you know, for years this is a joke and it actually exists now.
You actually had a video not too long ago about a Scotch Guard type
Yep.
material that you were suggesting all us Faraday J-pole owners now can use to keep it weatherproof. So I thought that was brilliant.
Yep.
Okay, any other questions in the room? Okay, Shree's got a question.
Shri, KA6Q. Actually, a comment or a add-on to, there was a question about HF antennas. And there's one fun thing that I did a couple of years ago, 3 years ago or so, was using Faraday cloth, built a instance of Mike Willard's anti-jamming antenna. I don't know if you've heard about it. Originally it was made like a piece of aluminum foil on a tabletop. And it's intended, it very nicely suppresses local jamming. That was the Cold War idea.
Right.
We can
Yeah.
in the 1960s, but you can make that a Faraday cloth. Mentioning that it works very well as a HF receive antenna. For HF transmit, it doesn't matter. Use your, whatever metal duct that happens to be around. So that's one application that can be done for HF.
Right. And absolutely using like if you look at KB9VBR, I believe is his call sign. He's got a YouTube channel, and he's the one who sort of started the magic carpet thing, where using a wire screen on the ground for counterpoise. Then he found the Faraday cloth. And again, watching those videos on YouTube are the ones that also helped inspire me to go down the rabbit hole of Faraday cloth and find the Faraday tape. So, I definitely have to, thank him for that. But what I'm getting at is that you can use it for counterpoise as well, and as a ground plane, or sew up a disc cone antenna, but actually have a disc instead of just several wires pointing down. When you look at HF and you look at my random stick, let's start looking at things that this can be a dipole. They can be two elements coming out side to side, but imagine climbing up into your attic, and nobody likes climbing into an attic and then going to the very end and stringing wires back and forth. If you had one of these random sticks, you could literally just extend it out from the porthole going up into your attic, and another one out the other side, and then drop the wire down. And it's become a lot easier to do that sort of installation. I've done a video I need to get out is a delta loop, but I did a V delta loop where you have the bottom of the V at the bottom, and then I did a cross wire at the top. That antenna weighs 3 pounds. It fits in my backpack, and I've heard echoes of myself coming out the backside on 100 watts. So just find an antenna and start using these as sticks and start seeing what you can do. But they weigh nothing, and you throw in a backpack. It's so much fun.
Way cool. We'll tie it up real quick.
I had one question.
Oh, you had one. Okay.
If all the other questions are over.
Yeah.
Bob KN6YGN. I'm just curious. I've been sitting here. My mind's been going in circles, just trying to think of like creatively what could you do with some of this stuff. And I'm curious, like what's the oddest thing that you've taped up? Like have you tried to make an antenna by taping up a swimming pool or anything?
Okay, there's a video coming out next week. Is anybody familiar with Meshtastic? Anybody play with Meshtastic?
Becoming very popular.
Okay. Let me introduce you to the mesh tie stick.
Nice.
So this is a necktie, and the mesh, the electronics and everything are just in here, including the battery. And that's the antenna. So that's one fun thing that I've done. And then one
You're-
thing that I want
You're
to
getting quite
recognize,
the applause in here right now.
yeah, that video. So I hate promoting my stuff and I don't want to be the guy selling things. So like, yeah, I do sell the antennas, but don't understand that I'm not that guy. But I also have a Patreon, and the Patreon I run, you get to see my videos a week in advance. So the week in advance is that that antenna there that I just showed you is the necktie one, but I'm gonna pull up Roth Hamel's book here. I'm hoping you can see this
We
style
can see it.
antenna here.
Yep.
Yeah, we got
Okay.
it.
So what's really interesting is that what you're going to find in that video that's coming out next week, it'll be next Wednesday, is that we've taken Faraday fabric and we've done a iron-on backing onto it. So you can buy this biasing tape, I believe is what it's called, or a biasing sheet. So we've ironed it on, and then I've run it through a Cricut cutter to cut out, because the 900 megahertz, when you're working on 2 meter antennas and 70 centimeter antennas, there's quite a bit of wiggle room as far as like, if I make a mistake of 1 or 2 millimeters, it's not going to affect things so much that it's not going to work, right? But when you start getting into 900 megahertz, things are tiny, and like half a millimeter changes everything, and I'm not that accurate. So using something CNC like the Cricut or a laser cutter will allow you to do that. So now let's just take it a step further, is that you can do an iron-on version of this bow tie multi-band, or effectively it is a log periodic in a bow tie style, and you can iron it on to a pack or something like that. And I'm working on some military applications with that, because when you have a ceramic plate or something, you have some protection from the RF, and you can have a broadband antenna that is literally ironed onto the uniform. And that's kind of where some of the stuff that I'm going for now is getting really interesting. So yeah.
Yeah, yeah, this is all really fun to think about. You've talked about things that you can roll up and take in your pack, or have these iron-on things and whatever. It occurs to me you could probably make a tent into an antenna, right?
Yeah,
And then
well, you
could
can.
sleep
Now
in
you
your
gotta
antenna
remember,
at
like,
night.
start looking at exposure though, is like how many watts, what frequency, how far do you want, you don't probably don't want to be inside that tent when you're transmitting, but it
No,
will.
no, no. But you can sleep in your antenna when you're not on the radio, basically.
Yeah, no, very much so. And something just occurred to me, is there was one thing I tried recently, is we're talking about making string out of Faraday cloth. So what I did is I took paracord, and I pulled all the cords from the inside out, and then I ran Faraday fabric, just rolled up piece of Faraday fabric to the inside of that, and that has become my floppy element. So I just weave that into a chest pouch on me, and I use that as a 2 meter antenna. It's a zigzag, it doesn't get out very far, but like, it works, and I don't have any antennas flopping around me. No, I'm ex-military, and I've dealt with these situations, and antennas are an absolute drop in an F-bomb nightmare. You hate them. So if you can get them so that they're tactically just part of your uniform, that changes the game. Yeah. But so with the paracord, that it's not really a string, and you've taken a lot of the strength out by pulling those inner cords out, but it is a cord that you can use. Yeah.
There's a question from Tim KO6EMS. Have you ever experimented with any fractional design similar to fractional UHF, VHF TV antennas?
Yeah, the fractal antennas, well, the bow tie one is like, I'm trying to think. No, the bow that log periodic bow tie is not a fractal. I've been looking at fractal antennas. I'm just learning how to cut some of these more basic shapes, but the fractal antennas would be definitely something to look at. It would be a lot of fun to play with. And again, you know, let's go back to, I'm using Faraday cloth. Now, Faraday cloth is great, and you can sort of cut it, but I think if we're looking at, you could make a decal or a sticker out of copper foil and laser cut that. That'll easy, lasers like the UV hobby lasers can cut through that foil. You'd be able to cut something very intricate that you could place onto a substrate and go from there. So yeah, that'd be kind of fun.
Hi, this is Connie W6EFI again. Um, is how much of the information about the manufacture of Faraday textiles how much of that is open? I'm wondering, I knew nothing about how it was manufactured before tonight. You mentioned vapor deposition
Yeah.
of copper or titanium. Is that process documented anywhere? And the reason I'm asking that is because I was thinking about the string issue, the lightweight, strong string, Faraday string. If you, I mean, strong Kevlar, yeah.
Oh my goodness.
Kevlar string exists. That's
Well,
copper.
the
Not copper,
Spectra is
that's
stronger than
carbon.
Kevlar, but I'm going down the rabbit hole that you're putting here. Oh my
Yeah.
goodness.
How would you,
I-
you know, vapor deposition on that Kevlar string, which is so strong and light and invisible that it's dangerous.
I've got
I mean, you could take
goosebumps. Oh
somebody's
my
head off
God.
with that stuff.
That's
So,
crazy.
okay, so anyway, there you go. There's an, have fun. 73.
I don't know it exists. I'm hoping that I can make it exist because what you just pointed out is crazy because yeah, at that point, get rid of all these super strong copper wires. It's also super lightweight. You could wrap it up. Oh, I'm speechless. Well done.
I think this is the first time our audience made our guest speakers speak.
Because I am working on taking the Faraday fabric itself, doing a 10 millimeter wide piece. And here, let's see if I can find it. So you've got these kinds of like rollout tapes. So you know how they roll up into something like this. And I think a few people have got like USB cables that roll out on either end. So I'm doing this, but I'm using my Faraday tape on the inside. So I'm using that as the long element. So you can just have like this little small disc that you can carry with you to use as a dipole out in Poto and Soda. But if we could create that string, I think it would be lighter, stronger, and better. Damn it, now I got another thing to work on.
Oh, yeah, for the kite. Okay, we got one more question, then we'll have to probably start wrapping it up pretty soon. Kite string, right? Here you go.
More of a statement. If you figure out that Kevlar vapor deposition, I will immediately order 5,000 feet from you. That's not an exaggeration. I need 2,000 feet of it pretty soon for some fun projects. That would make my life a lot easier. And
Okay,
if you
well.
don't sell that tie, I will come to Canada and steal that one.
Well, I'm gonna make a bow tie one. That one is gonna be mine. I made that one just as a proof of concept, and it works like a hot darn. But the bow tie is the extra nerdy version that I'm gonna have to keep for myself. I'm gonna leave this conversation with one thing I discovered recently. So, I'm sure most of you know Mythbusters and know of Adam Savage. Because of my nature of my work, I've gotten to work with him, and he is a friend of mine. So if you go on to Tested, you'll find that there's an episode that I did with him on using the Faraday tape for some cosplay applications. But this here is conductive hook and loop or conductive Velcro. So you can, when you talk about linked dipoles and everybody trying to figure out how to do it, it's as easy as just sticking them together. And with that, I'll leave you.